Hi friends, happy Thursday. I hope you're ready for another fraction video. Today is actually our review for fractions because we are having our quiz tomorrow. So make sure you are really trying to work through these practice problems along with me, okay? So let's get our slides all set up. As always, it's going to probably take me forever to get it to load, but what else is new? Oops, wrong thing. That's okay, we're learning together, right? So, once this decides to load and we can present it, we're going to get going on our goal for math today. So, today we're just kind of getting practice with what the idea of a fraction is. Like I said, we are going to be having our first fraction quiz tomorrow, so we need to make sure that we really feel comfortable with what a unit fraction is, what the numerator is, the denominator, a lot of that vocabulary that we've started working with this week. So, number 1 says the part shown is 1/6 of a rectangle. Draw a model to show what the whole rectangle might look like. So again, this is very, very, very similar to the ones we did yesterday on here. So this one little cube is 1/6 out of the entire rectangle. And we know that if the denominator is 6, that means there needs to be 6 total objects, or 6 total cubes, 6 total apples, whatever the problem's asking. In this case, it's just a square. So we know that we have to have 6 of these rectangles to make a whole rectangle. So if you need a pause, go ahead and make that picture in a notebook on a separate sheet of paper. I am going to be pressing enter now. So this is a possible drawing of your shape. Again, it could go up and down. If you drew up and down, that is more than okay, as long as you have 6 pieces that are relatively equal in size. I know that drawing is a lot more difficult than doing it on a computer or anything, so if they're not exactly equal, that's more than okay. You have all seen my drawings. I can guarantee you that my drawings would not have perfectly equal squares. More than okay, as long as you get the idea that 6 rectangles or 6 squares need to be in this rectangle to make it a whole one, since the denominator of our unit fraction is 6. Now, we have to look at these squares, and each is divided into equal parts, which means all are valid to make a fraction with because they have equal parts in their model. So, Lynn says each square has the same fraction shaded. Rose says each square has a different fraction shaded. Who do you think is correct and why? So first, let's go through and label the fractions for each of these models. Obviously, I wish I could write on this. The one downfall of recording it this way is I can't be writing on my screen, but stick with me while you can. If you need to pause to write stuff down, again, as always, more than okay with me. So this first square looks like it's divided into 4 smaller triangles, not rectangles. Sorry, Miss Dion's a little cuckoo today. Clearly, I don't know my shapes anymore, but this is divided up into 4 equal-sized triangles. Now, if we look, there's 4 total and 1 shaded in, so we know it's a unit fraction because 1 is going to be in our numerator, and we have 4 equal parts. So our fraction for this one would be 1/4. Now, if you need to write that down, just try to keep that 1/4 in the back of your mind for the rest of these. Now, for the second square, it looks like we have 4 different rectangles, so it looks like we're going to have the same denominator as this one. And it also looks like we might have the same numerator because, look, we only have 1 shaded. So that means this one has a 1 in the numerator and a 4 in the denominator. So again, it sounds like we have 1/4 as a fraction. But just to be safe, we want to make sure Rose is completely correct or Lynn is completely correct. We want to check every single option. So let's also check this last one. And it looks like, once again, instead of rectangles or triangles, we now have squares. And it looks like we have 1, 2, 3, 4 squares, 1 shaded in. So again, we have the unit fraction 1/4. So if this model is 1/4, this model is 1/4, and this model is 1/4, who is correct, Lynn or Rose? Remember, Lynn said each square has the same fraction. Rose said no, they don't. So who is correct? If you need to pause, go ahead. So who was correct? Who said that every fraction was the same? Lynn. Each of these models is showcasing 1/4. It's just a way to show you that shapes can look different and still equal the same fraction. So if we look, each of these models still has 4 separate parts and 1 shaded out of those 4 parts. And that's just saying Lynn is correct because each square is the same size and divided into 4 equal parts. One of the 4 parts is shaded, so each square has 1/4 shaded. Now we have to look at this one. Look at these triangles, and each is also divided into equal parts. What is the same about the fraction of each model that is shaded? So what is similar? And then you're also going to go and say what is different. So again, if you need to pause, go on, do that. So what is the same? The fractions are both 1/2 because each is divided into 2 equal parts and 1 part is shaded. And what's different is that they're different sizes. So the amount shown by 1/2 is different. They're still showcasing 1/2. They're just showing it a little differently. The smaller triangle is a smaller 1/2 than this bigger triangle, which is obviously visibly larger. And it's still 1/2, but just a bigger piece. So you can think about that as handing out apples, I guess, to a classmate. You could have 4 apples and be dividing that up into 2 separate groups. Say this is the smaller triangle is group 1 and this bigger triangle is group 2. If you give the 2 smaller apples to these 2 friends and only one eats it, and if you give the 2 bigger ones here and only one eats it, this one is still eating something bigger. It's still a bigger shape because it's the bigger apple. I hope that analogy made sense. If it doesn't, let me know. I'll try to think of something more creative. But it's just saying that this one's bigger, this one's smaller. Obviously, they're both 1/2, but you can just see the size difference. Now, we're talking about pizza. Happy fractions. We're always going to be talking about pizza or pies with fractions. So, Adam has 1/3 of a pizza, Hillary has 2/6 of a pizza, and John has 3/8 of a pizza. Sounds like Adam, Hillary, and John are a little hungry if you ask me. But what we need to do now is you need to draw models. I would suggest doing it on another piece of paper so it's easier, of their different pizzas. So Adam's, if we look, is 1/3. So if we look at his denominator, his pizza should have 3 equal size pieces and one of them shaded in, meaning he ate it. Hillary has 2/6 of a pizza, so her denominator is 6. So her pizza should be divided into 6 equal pieces. Now, John has an 8-piece pizza, so he needs to have his pizza divided up into 8 equal parts to make his match up with his. So John ate 3, Hillary ate 2, and Adam ate 1. You need to show in a picture by shading in what they have eaten, what their pizza now looks like. So if we read part A, it just show the number of equal parts, then shade in their pizza. And then part B is circling one of the pizzas and explain how you knew how many equal parts to show and how many parts to shade. So if we look here, Adam has 1 piece shaded out of 1, 2, 3. Hillary has 6 pieces total and 2 shaded in. We just can't see the line because the coloring on the slides is the same color as the lines. And then John was supposed to have 8 pieces of pizza, so let's see if he still does. So we have 1, 2, 3, 4, 5, 6, 7, 8. So he has 8 pieces, and his numerator is 3, so he ate 3. So we are going to shade in 1, 2, 3. So possible answer for part B is if you look at the denominator to know how many equal parts to divide the pizza into, and then we look at the numerator to know how many parts to shade. Remember, denominator is always the number of equal parts, and the numerator is always the number shaded. So now, time for our exit ticket. Mike has a circle divided into equal parts. 1 part is shaded and the other 3 parts are not. Mike says his circle shows the fraction 1/3. Is he correct? Draw a picture to help you explain. So Mike has a circle divided into equal parts. So we know that when we draw this circle, each part needs to be the same size. So 1 part is shaded and the other 3 are not. So if 1 is shaded and 3 are not, what will our denominator be? The denominator is going to be 4 because we have 1 part shaded and 3 parts not. So we're going to have a circle divided into 4 equal parts. But we only have 1 shaded, so that means our numerator would be 1 and our denominator would be 4. But Mike says his fraction is 1/3. Is he correct? No, because he didn't count his parts right. He said 1 part is shaded and 3 parts are not. He just looked at the 3 parts are not, and it looks like he just made that his denominator. But really his denominator should be 4 because we have to also account for the 1 that's shaded. So let's look at the picture to help us. So Mike is incorrect. The circle shows the fraction 1/4 because 1 part is shaded and the other 4 parts make up the whole circle. Mike used the number of unshaded parts as the denominator when he should have used the total number of parts altogether. So he didn't count for the 1 shaded, he just counted for the ones that didn't have anything shaded at all. So he was incorrect. So make sure when you're reading problems like this, you are being very careful. This was tricky because it just told you 1 part is shaded and the other 3 parts are not. You might have a question like that on your comprehension check tomorrow that tries to trick you. Make sure you're reading everything slowly and you're really paying attention to what the picture is saying. If you need to, you can always draw a picture on a piece of scrap paper in a notebook, whatever helps you the best. And with that, you are done with math for today. If you would like to, you can go on to iReady to work on some lessons on your path. But since we are completing this review for today, you do not need to. It's not necessary. But if you do have any questions, we do have our comprehension check tomorrow, so make sure you're asking them. You can chat me on Google Hangout. You can video chat with me there. Just let me know if you need me. Have a great day, guys. Miss you.